Okay, so here we are in the technical video for day number 20, where we got a capacitor. I'm excited about this capacitor. The specific component that we have is called an electrolytic capacitor. They're these like barrel capacitors. You'll see them all over the place. Here's what they look like. This is the Open Circuits book. I've shown this several times. But this, here they are in circuit. I've shown this before, but here's kind of what they look like. They're like this wrapped up thing. If you imagine wrapping up like a tube of aluminum foil, is one way to think about it. It's rolled up, and the dielectric is kind of in between these slots. You can basically see it here, like in between these pieces. And as it says, it's sort of stretched out, etched in such a way as to substantially increase the surface area and thus its capacitance, which is interesting. I actually didn't know that. So there it is. That's what we have physically. Now, these are used all over the place. They're used for power supplies. If you open up anything that has its own power supply, you're going to see electrolytic capacitors. Now, if I turn this on, see, this time it's fine. There. Holding it like this guy's not moving at all. If I do this, he's going now, but now he's not moving at all. Actually, I just noticed looking at this schematic, they changed this. This actually doesn't pull up here. It changes here. I just noticed that. I don't think they mentioned it anywhere. They probably do, and I just missed it. But I don't see it just, going through this. But they changed this. So this resistor, this is the same circuit, except that this resistor is not where it was. It was here. It was connected directly up here. Not here. So that I can put this back in here. Right there. Yep, okay. Let's pull that guy out a little bit. Okay, does that help? I'm still getting the same issue. Okay, so I did some more experimenting. I'm starting to think that this is light pollution. So I've rewired the circuit a bit here so that the lighting element is here. That this thing is going to be like that, right? I just have it on this clamp to make life easier. So it's going to be rotated like this, which means that this is going to face down. Before it was facing up. So I think it's the light pollution that's happening, because if I just turn this on, I can feel it kind of, but if I cover it, it's like much more womp womp, like it's my technical term. It's not as bad here, but I'll bet if I move the camera, yep, if I move the camera, it's just off. The shadow of the camera is causing the issue in this case. So having it face down, I think is going to be much better. And of course, once we have the actual cover on this thing, then it's going to be considerably better, because there'll be no light pollution at all. Here's the actual cover, by the way. So we'll have like a full cover on it. So I'm curious if this is going to solve it. I'm going to create the other side of it, but I'm pretty sure it's light pollution that's causing the weirdness. It would also explain the non-consistent nature of it. Yeah, so the light pollution thing is looking more and more likely. Here it is on the oscilloscope. So that's just in roll mode. If there's right now enough like blocking of the light, but of course if I were to shine a light on it, you can see it just cuts out, which is of course what the circuit is designed to do. Okay, we're now back on the bench. Let's see what happens. There we go. It's still doing a little bit, but not as much. I have to kind of cover it, or else it starts to gain that light pollution again. And here we are with most of the ambient light off. So I've turned off my overhead lights. All I have is the room light, and it's working pretty much as designed here. So this light pollution is going to be a real issue, but that's okay. It works now, and that was definitely what the issue was. So this physical redefinition of the circuit, I think, works well. So there we are. All right, I'll see you tomorrow.